Okay, we're going to talk a little bit about pigments and paints. And the nice thing about pigments and paints is they're pretty easy to do once you know how to do light and how to mix light. Now we're going to actually mix paint, mix pigments, and kind of see what they do. Our color wheel changes a little bit because now our primary colors are no longer going to be red, green, and blue. Now the primary pigments are cyan, magenta, and yellow. So I'm going to put cyan here, magenta here, and yellow here, and I'm going to circle these. Oops. In fact, I think I'm going to box them. Because remember, we had boxes around our primary colors, and then our secondary colors were blue. We're going to put green here, and we're going to put red here. So it's essentially the same thing. You still have your same opposites, but this time instead of the green being primary and green and red making yellow, now yellow and cyan actually make green. So your printer at home, if you have a color printer, would work this way. Magenta, for what we're doing, is going to absorb green. So they're just the opposite. So magenta absorbs green, cyan absorbs red, and yellow will absorb blue. So those are kind of the three colors that we've been dealing with light. Now we're going to switch and use pigments of color. So we have the three pigment colors that are primary. What paint colors can be used to paint a boy if he has pink, magenta skin, blue jeans, a blue and yellow sweater, and a black and white baseball cap, cyan socks, and red sneakers? Now, we can say that that's styling. So anyway, his pink skin, they already have given you that one. We know that that one's got to be magenta. So that's what we're going to call pink. His blue jeans need to be blue, but you can't use blue paint because there's no such thing as blue paint. Blue paint is really cyan plus magenta. So if you remember our color wheel, that's kind of what we did for paint. One more thing that we'll do is we'll talk about the yellow part of the sweater. That one is going to just be our yellow pigment of paint. So you're going to do the rest of these trying to figure out what colors you need to put together. I will tell you, when you put the three primary colors together of pigments, cyan, magenta, and yellow, you actually will make black. You won't make white. That does not work. So when you mix the paint together, you'll make black. That should help you with these two. Um, the absence of color the absence of these colors is going to give you white. So if you don't use any color, you can get white. That should help you with some of the rest of these. For the next one, suppose you and your friend are starting to get a little carried away with your enthusiasm for the physics of color. It's very understandable that you would do that. And rather than seeking professional help, you begin discussing the colors of your favorite NFL team uniforms in terms of primary pigments that have been imparted to each of the items. So, oops, I'm going to back this up a little bit. Oh my, that's just going to go everywhere. So essentially what we're going to do is we're going to turn this on again and go back to where we were. So we're looking at these NFL team uniforms, and notice that the helmet part here is yellow. So what pigment would you need? Well, it's the same type of thing. You would definitely want yellow pigment because that is the primary pigment. If I want blue, once again, we have to use cyan and magenta paint. You have to mix those together. So those colors will then make the blue. I'm going to have you finish these next three. Going on, we now have this really pretty parrot, and you need to figure out what colors you're going to use in order to make each one of these colors for this really nice looking parrot. Red wings, of course, are not going to be red. They will appear red, but the two pigments that we need to use are going to be magenta and yellow, and that will make the red. So I'll let you figure out what the cyan, the blue, and the green need to be in order to finish our parrot colors. The next question that they ask you is, they're showing you a very colorful physics demonstration, and it says in this one that Clairvoyance, so get it, Clairvoyance, uses three colored spotlights, red, green, and blue, equal intensities, illuminate a sheet of paper with different colors of light. And as she does that, she paints the paper with various combinations of pigments. She asks her students to predict in advance the color of light that she'll be able to see. So we've got a spotlight that's red, green, and blue. Remember, that would be all the colors of light. So that's actually white light. We've applied cyan to the paper. So the paper should appear cyan. But remember, the opposite of that is going to be red. That will be the color that's absorbed. Let's do the next one. We've got red, green, and blue light. We have cyan and magenta for the paper. So the two colors that are absorbed are going to be red and green. Remember, opposite of cyan is red, opposite of magenta is green. So this paper, when you look at it, should appear blue. We'll look at the next one, and then I'm going to let you finish the rest of these, and then we'll look at them in class. I have red and blue light. So notice that there is no green to reflect at all. We have cyan and magenta paper, so now we have red and we have green light that is absorbed. So if the red light is absorbed, okay, and so is the green light, uh, oops, this one, we don't have any green light absorbed. And you'll notice that that's true because there's no green light coming from the light. So the only color that I have left from the red and the blue is going to have to be blue. So let's just look at this one more time. We're going to have red, green, and blue light. The pigment in the paper is cyan. The light that is absorbed is red because remember, cyan is basically a mixture of blue and green light. So you could put blue and green light here. And so the color that you would see would be cyan. If I have red, green, and blue light, and the pigment that's applied to the paper is cyan and magenta, the opposite of cyan is red, and the opposite of magenta would be green, so those are absorbed. So the only color that we're going to see is going to be blue. On the next one, we have red and blue. Notice there is no green here. So the light that is absorbed is just red because you can't absorb green. There's no green light. If the red is absorbed, then we've got to go back and say, okay, I know I have red light coming in. It is not going to be, it's going to be absorbed, so you cannot reflect it. But the blue is not absorbed, so there's no blue here, so that's the color that we see. Let's do one more. We have red and blue, and this time we have cyan and yellow. The opposite of cyan is red. The opposite of yellow is blue. So both the red and the blue this time are absorbed, and this paper appears black because there's nothing that's reflected. If we go back up, you'll notice that the red and the green here get crossed off, and that leaves you with blue. And on this one, the only thing that gets crossed off is just the red. So it leaves green and blue, and remember, blue and green light, when it comes back and hits your eyes, is cyan. I'll have you go ahead and finish the rest of these. We have only one more topic to kind of really talk about and go through here, and that is objects that are filters. So these little plates, if you remember, are filters. This is a magenta filter. And if it's magenta, we have to think about what is the light that it absorbs. Well, if you look at the other side of magenta, okay, if you look at the other side of magenta, remember that one would be green. So this thing is going to absorb green, so green gets to stay within here. We cross it off, and the two colors that come through are red and blue. Let's look at this one. Magenta again, so green is absorbed. So this filter will only allow the red light through. So if I only have red and green lights on, they pass through this filter, the only light you will see coming out the other side is just red because the green is absorbed. We'll do one more. We have green light absorbed in a magenta filter. So blue-green, we cross off the green, and we're going to be left with just blue light. I'll have you finish the rest of these, and then we'll check them in class. And that concludes the video that we have here on pigments and on paints.